Hello everyone, welcome to our project demonstration. Today we will be demoing the 3-class ResNet model, which was the most accurate of our models, along with the learning rate of 0.007, which was the best learning rate for this model. When you start the program, it prompts you with the command to either enter testing or demo mode. Testing mode was used for the purposes of collecting data, where it runs through the full training set and then tests based on the testing set, while demo mode runs through the full training set to train the model, but then allows you to select images to make predictions on. So when you start demo mode, it displays the spread of data. So we can see that there are approximately 5,900 total data entries, and it shows the split between the training and testing sets, with a 75-25% bias towards the training set. Our program runs through 5 epochs for training. It also trains in batches of 10 images. So in total there are around 440 batches per epoch that are run. The training takes a good amount of time, so with a little movie magic, I will be back to you with the trained model. As you can see, the model has finished training. After 10 batches, the model prints out the epoch number along with the average training loss for that set of 10 batches. We decided to do this to make the model more responsive during training and indicate the progress as we go along. We also print out the total training loss of each set of 10 batches, so 100 images, and there's also a strong downward trend in this loss number. So after the model trains, the command line prompts you, the model is ready to make predictions, and you can enter file names or type E to exit. I have a few images that have been submitted by the class that I will go through now. So we'll start with a few mask examples. So the guess is printed to the command line here, and the figure is shown with a label. These are in the original aspect ratio for display purposes, but the images are transformed into a 224 by 224 size for the sake of training. Here is another example with the mask on. Once again, correct. Now we will look at a few examples of mask improper and mask not being worn. These are the more difficult classifications. So once again, correct. Face with mask incorrect. Usually a key indicator that the model will get it right is that it can see the mouth or the nose. So it will oftentimes misclassify images if the nose is partially covered by the mask or if the mouth is covered and the nose is exposed. Here's a more tricky example that Jay submitted. As you can see here, he had the mask slightly further up, so it's classified as face with mask even though his nose is exposed, and it is a face with mask improper. Here's an example from Ted with no mask. This one was misclassified as mask incorrect, but I think this may be because of the lighting in the photo. Also, based on our effective correct metric, this will be classified as a correct prediction since it is in one of the two improper mask usage categories. Here's another one from Ted with his mask on correctly. In circumstances where the mask is worn correctly, it's almost always guessed correctly by the model. Here is another improper mask wearing from Emma. This one has been classified correctly. Once again, has both nose and mouth visible, so the model has been fairly accurate with these historically. I have a couple improper ones that I uploaded to. This first one is more of an easy example where mouth is clearly visible, nose is clearly visible. Second one, I had the mask slightly higher up on my face, covered my mouth. And it also got this. Once you're done making guesses, you can exit by just simply typing E, and the program ends.